In this question, we want to determine the value of k such that the vectors shown have an angle of 120 degrees between them. Okay, well, what we're going to do is we're going to set up a dot product. We're going to say that 1, 2, 1 dotted with negative 1, 1k is going to equal the magnitude of the first times the magnitude of the second times the cosine of 120. Okay, well, using the component methods, we see that the dot product is negative 1 plus 2 plus k. And that has to equal the square root of 1 squared plus 2 squared plus 1 squared, which is root 6, times the square root of negative 1 quantity squared plus 1 squared plus k squared, which is root k squared plus 2. And the cosine of 120 is negative 1/2. So this is going to have to be true. Now, this side simplifies to k plus 1. This side simplifies to, if you take this first term and third term and multiply them, you get negative root 6 over 2. In other words, root 6 times negative 1 over 2 is negative root 6 over 2. And that's multiplied by the square root of k squared plus 2. Now, what we're going to do next is multiply both sides by 2. So 2 bracket k plus 1 is going to be negative root 6 times the square root of k squared plus 2. And at this point, we're going to square both sides. Now, we're playing a dangerous game because we don't know if k is positive or negative at this point. And we have squared term underneath the square root sign, and we're going to be squaring both sides. When we start playing games like this, we have to make a point at the end of checking the validity of our answer. So whatever answer we get, as soon as I start, after taking the square root, then squaring both sides, as soon as I start doing that with a value that could be positive or negative, I realize I'm going to have to check the validity of my answer at the end. So let's square both sides. 2 times 2 is 4. K plus 1 times k plus 1 is k squared plus 2k plus 1. Negative root 6 times negative root 6 is positive 6. Square root of k squared plus 2, quantity squared, is k squared plus 2. So we get 4k squared plus 8k plus 4 is 6k squared plus 12. We have a quadratic. We set it equal to 0. 0 is 2k squared minus 8k plus 8. That means we have 2 times k minus 2 times k minus 2. And that means that k must equal 2 in order for this to happen. But, like I said, keep in mind that we had the cosine of negative 120 equaling negative 1/2, and that we had a negative number here that we ended up squaring. So we were playing games with the signs of our terms, which means that what we have to do is go back and check if k equals 2 does in fact give an angle of 120 between these two vectors. Well, what we can do is take the dot product. If I let k be 2, 1, 2, 1 dotted with negative 1, 1, 2 is going to equal 3. Well, if you have a positive dot product, that means that the angle between the vectors is acute. But we're saying that the angle between the vectors is 120. That means that there is no such angle that exists. So since k value of 2 gives a positive dot product, it therefore means that a k value of 2 provides an acute angle between the two vectors given, which means it's not an angle of 120, which means no such value for k exists. Because the question said, determine the value of k such that the angle is 120. And the only possible answer we got was k equals 2, which is not valid. So there is no such value for k.